It's block, yes. All right, so 2, 6, we're just going to combine A and B because B is really just one example. So I'm just going to teach it all to you in one shot today. But it is ratios, rates, and conversions. Conversions are like one of my favorite things ever. So hopefully you love them too. All right, here's what we're doing. Can anyone tell me what a ratio is? Compare, right? You compare two things. So like if I said the ratio of boys to girls in this classroom.
There's so-and-so girls to boys, something like that.
Well, if I said boys to girls, so which one comes first?
Girls.
Boys, right? So depending on how I say it, the ratio of boys to girls would be the number of boys to the number of girls, right? So in this room, there's 3 boys. Poor boys. You're way outnumbered. So 3 to, what are there, 9 girls? So 3 to 9, which you could then reduce to 1 to 3, okay? So a ratio is just comparing two numbers. Really hot? I was going to say, I'm not hot at all. So it can look like this. A ratio might be A over B, but we say it A to B, okay? Or you can do it A colon B, or you can just say A to B. But all of them are said A to B. It's a comparison of those two numbers, okay? A to B. It's a colon. My dots just didn't show up very nicely, but it's 2 dots. Okay? So if I had this setup, should have one of you to come up here and do this instead because I am not an artist. We're going to pretend these are flowers.
Those are flowers. They're cute too. I wear those.
You would wear these? Oh, that one's bad.
It's okay. The petals just missing. They look like popcorn.
They do look like popcorn. Maybe we'll do red popcorn to
Wow, they look like flowers. Popcorn's yummy.
blue popcorn. Okay, so my flowers here. What's the ratio of red to blue?
3 to 4.
Right, 3 red. What? No. You have to look at what they asked you for. So if I said what's the ratio of red to blue, the red number comes first, the blue number comes second, right? So what's the ratio of blue to red? That would be 4 to 3. Okay, so it doesn't have to be that like the bigger number is first or the smaller number is first. It's whatever they gave you as your wording. Thank you, sir. Ryan, this is for you. Okay, so that's ratio, okay? A rate, what's a rate? Like if I said a rate of speed, what am I talking about? Give me an example of a rate for speed. What do you do on the freeway? Miles per hour, right? It's comparing miles per hour, okay? Kennedy, will you put your iPad away, please? So, excuse me? Sneezing?
What?
I don't know. So a rate is something like miles per hour, okay? Or you can think of it as miles per hour, right? That's a rate, miles per hour. Or you could say feet per second, okay? That would be a rate. So we're going to be dealing with some different rates. Sometimes if we go to the grocery store, it's dollars per ounce, how expensive something is per ounce of whatever it is you're buying, okay? Those are all rates. A unit rate is going to be one of those, but your denominator, which one's the denominator? The bottom one. Sorry, I'm kind of running out of room here. The denominator is 1 if I talk about a unit rate. So basically what happens is whatever your rate is, if it's 55 miles in 2 hours, you just divide it. 55 divided by 2 to make that bottom number a 1. Okay? That's called a unit rate. And I'll show you some examples of that right now. All right, so first example, we're going to say we're going shopping for shirts, okay? And I want to know what's the best deal. So in store A, it is $25 for 2 shirts. In store B, it's $45 for 4 shirts. Okay, and in store C, it's $30 for 3 shirts. Okay, I want to know what's the best deal. So what we're going to do is figure out, well, what does it cost for 1 shirt? So we're going to find a unit rate for all 3 of these stores. Okay, that means we're taking the number or the cost of a shirt, of the however many shirts, and dividing by how many shirts that is, right? So my unit rate here would be 25 divided by 2, right? $25 per 2 shirts. So 25 divided by 2, you get $12.50 per shirt. Okay, so 1 shirt at that store would cost $12.50. So how do you find the unit rate for store B? 45 divided by 4. So you're going to do 45 divided by 4. When you plug that into your calculator, you get $11.25 per shirt. So far, which is the better deal? Store A or store B? Where do you want to buy your shirts? Store B, right? $11.25 per shirt. Store C, you're going to do a unit rate again. So 30 divided by 3 is $10 per shirt. Okay, so if I said, where are you getting the best deal? You want to go store C, right? $10 is the cheapest of the 3, right? So you would want to go to store C if you want the best deal. Okay?
I saw a wedding dress at Goodwill, and I was like, their wedding dress.
A lot of people don't care about their wedding dress once they're done with it. I have mine all boxed up pretty. Someday, if I have a little girl, I'll let her play in it because that's the only reason I would use it. Okay, so that is unit rate. You're just dividing by your denominator so that your denominator becomes 1, right? Because 30 over 3 is 10 technically over 1, okay? You don't need to put it over the 1 because we know it's as if there's a 1 there. We want it the simplest answer we can get, okay? Okay, on to my favorite, conversion factors.
Everything that's your favorite is super.
Is super what? Not necessarily. I have things that I love that are not difficult. Like I love solving 2-step equations, and I feel like those are pretty simple. Okay. Sometimes this is called unit analysis or dimensional analysis. If you ever take chemistry, you're going to do a lot of this. So learn it well here so you can do it well in chemistry. Basically what we're doing is we are converting like miles into feet, or we're converting dollars into cents, or we're converting minutes into days. Okay, so it's all these different. If I want to know how many days this chunk of minutes is, we need to do something to figure out what that is, okay? So basically what happens, don't write this down, okay? I don't want you to get confused on your notes. This is not a conversion factor, but I want this to lead you into thinking how we do this. When I did x over 2 equals 10, right? In order for me to cancel out that 2, we had to multiply, so that's a denominator. We had to put in the numerator something of equal value to cancel it out, right? So we multiplied by a 2 up there, and they canceled, right? That's what we've been doing the last few lessons, okay? We're doing something similar to that today, but instead of the numbers having to match up, it's the units that have to match up, okay? So here's what we're doing. If I say, this is example 2. If I say I have 330 minutes, and I want to know that equals how many hours? Okay, so that's what your problem is going to look like. 330 minutes equals blank hours. Well, we have to convert minutes into hours. And we need something that's equal to 1 to multiply by. So here's what we do. We take 330 minutes. Is that a numerator or a denominator? It's a numerator, right? Because technically we could say it's 330 over 1. We don't need to do that, but just it's a numerator. It's a number on top in the problem, okay? We're going to multiply by something so that we can cancel minutes and turn it into hours. So if I want to cancel out the minutes, and right now minutes is a numerator, where do I need to put minutes to cancel it out? On the bottom, because minutes over minutes is 1 essentially, right? We're canceling it. So we're going to put minutes here. And what do you know minutes turns into what? Hours. Okay? So you're going to go from minutes to hours. So we're going to put hours on top. That means these are going to cancel out and leave us with an answer in hours. Okay? So let's think about this. Hours to minutes. What number would go on top for what number would go on bottom? How many hours is how many minutes?
60 minutes.
Right, there's 60 minutes, okay, so 60 is going to go on bottom and 1 hour on top, okay? Okay, so if that's the setup, now when I multiply, so 330 times 1 is 330. 60 is on bottom. We're just going to divide that now. So it's like finding a unit rate all over again, right? We want 1 as the denominator. Yeah, Jayla.
So for like the denominator, would it always be 60?
No, because the denominator can totally change. You just have to make sure that these two are canceling each other out, and then you're going to figure out how many minutes and how many hours, or how many hours and how many minutes. It's a matter of just thinking through what makes sense there, okay? And I'll show you more of these. So at this point, what do I need to do? Divide it. So you're going to plug into your calculator 330 divided by 60, and you get 5.5. Okay, now here's the question. What's my label? 5.5 what? Hours, right? We canceled out the minutes, so you're left with hours. So you get that. Does that make sense? See why it's my favorite thing ever? So fun. Okay, this one gets a little more tricky, but it's not terrible. It just has multiple units to start with. So 5 feet, 3 inches equals some number of inches, okay? So we partially have inches already, but we also have the 5 feet that we're working with. So we need to convert that 5 feet into inches. So if I set it up like this, 5 feet, is that a numerator or a denominator right now? It's on top, right? Because we would think of it as 5 over 1. Okay, so that's our numerator. That's our top number. We're going to multiply that, and then there's always going to be this bar here. Feet converts to what? feet to inches, okay? And that's what we're trying to get to, right? Inches. So how many feet and how many inches, or how many inches and how many feet? Do you know? Think of a ruler. 12, right? 12 inches in 1 foot. Okay, so now here's what we have to figure out. We want to cancel our feet out. Where are the feet going to go? Top or bottom? On your ankles. Not on the top. We want to cancel it, right? Remember when we're canceling numbers, 1 on top, 1 on bottom, and we said the 5's on top right now. So you're going to put feet on bottom to cancel it out, and inches on top. Okay? Then ask yourself, and I would say first things first, figure out which one goes on bottom, which one goes on top, then figure out what numbers get attached to it. So how many feet with how many inches? Where does the 1 go? 1 foot, right, is what? 12 inches. Okay? So now what you have is a numerator and a numerator. You multiply across. What's 5 times 12? 60. Our bottom is 1, 1, and the feet got canceled. So there's nothing left there. So it's 60 what? Inches. Okay, but here's where you have to be a little bit careful. We said 5 feet, 3 inches is how many inches? You don't multiply it. We found this, right? 5 feet was 60 inches. So 5 feet, 3 inches is how many inches? We said 5 feet, this right here, 5 feet is 60 inches. But we want to know what's 5 feet, 3 inches. 63. You got to add that 3 on the end. Okay, so 5 feet, 3 inches is 63 inches. Does that make sense? Okay. 2 more examples. Glad you do. All right, example 3. It says a tower is about 1,815 feet tall. Okay, so there's a tower that's 1,815 feet tall. Okay, I want to know about how many meters tall is it. Okay, and I don't expect you to know this conversion because it's not a common conversion. But here's the beautiful thing. When you go into Google and you type in feet to meters, the first thing that pops up is a unit conversion for you, okay? If you don't like Google, in the back of your book, there's a page that has all kinds of unit conversions. So you may do it either way. I feel like the Google route is a lot quicker, so Google it, I would say. But if you want the back of the book page, I don't have it written down right here, but if you want to know it, we can look for it. So if they're saying 1,815 feet, and we want to know how many meters is that? Okay, what? Okay, but here's what here's a good point. Ryan makes a good point. Here's what I don't want you to do. I don't want you to ask Google what 1,815 feet is, because I want you to understand the process of how we convert them. That's a great point, Ryan. So here's what I want you to do. 1,815 feet. And we're going to turn that into some number of meters. Where is feet going to go on this ratio? On the bottom. We want to cancel it out. On top, we put meters, okay? So you go into Google and you say feet to meters conversion, and it's going to tell you that, or meters to feet, feet to meters, it'll tell you one way or the other. 1 meter is 3.28 feet. Not a common conversion, right? Did anyone know that? I'm guessing no one knew that. No.
I know it now.
I didn't know it.
1 meter, not the.
Right, the 0.28, yeah. Because that's feet to yards, right? And it's a meter stick or a yard stick. So it's very similar. So that gives you a good way to estimate it, which is good. Okay, so what cancels out right now? What unit? The feet, right? Top and bottom, they're gone. So if I multiply this, what's my numerator? Times 1,815, right? So you multiply, this is a numerator times a numerator, so you get 1,815. What's your denominator? 3.28. Okay, so do we want to say it's 1,815 divided by 3.28 meters? No. Not a good answer, right? That's just
Would it be wrong?
not a good, you would get partial credit because you're on the road to the right answer. But what do we have to do with that? You need to divide, right? 1,815.
Oh, I thought you were saying that if we divided it, it would be wrong.
No. If you divide it, you're right. If you leave it like this, you're wrong. Or not fully right. So we would say that this 1,815 feet works out to 553, we'll just round to the nearest tenth, 0.4 meters. Okay? Questions on that? Okay, are you ready for my favorite one?
No. Yeah.
Yeah, you are. Okay, this is the last one. We're going big and then going home.
You can't go home. You have to
No, you can't go home. You're right. You need to stay here. Okay, here it is. A student ran the 50-yard dash in 5.8 seconds.
50-yard dash in 5 points.
Can you do that?
No.
I did the 40-yard dash in 4 seconds.
That's kind of fast.
Yeah?
He said that's kind of fast.
You're quick, huh?
He doesn't go
Okay, so we want to know what's their speed in miles per hour. I should have looked up combine speeds. Those guys are crazy fast, huh? So 50-yard dash in 5.8 seconds. Here's the thing. Normally, we've started with just a numerator, right? We've just started with one number, like 300 minutes is how many hours? Now I'm giving you two. I'm telling you yards per seconds, okay? So we're gonna start this one with 50 yards. You know what? Maybe, well, you're probably fine. This one has a few different conversions to it, so give yourself plenty of room here. I'm gonna move it over a little. 50 yards over 5.8 seconds. Okay? Now here's the thing. We want to convert to miles per hour. So we have a few things to get through before we can get to miles and hours, right? Let's do this. If our first conversion, okay, we're not going to try and convert both at the same time. We're going to convert one at a time. So yards has to turn into what? What are we looking for? Miles, right? We're looking for miles. So if we're starting at yards and we're going to miles, does anyone know a conversion from yards to miles? I don't. That is not a conversion from yards to miles. To a lot of things, not to this math question. Okay, so here it is. If I'm going yards to miles, what do you know? Yards to what? 3 what in a yard? Feet, right? Okay, so let's start there. If I want to cancel out yards, where does it need to go? On the bottom. We said that's going to convert to feet. Okay, so our yards will cancel, and we'll have feet instead of yards. How many feet and how many yards? 3 feet in 1 yard. Okay? Okay, but we don't want feet. We want miles. And now this one, we'll see if you remember. Where do feet need to go if we're going to cancel them? On the bottom. Right now it's on the top, so we're going to put feet on the bottom. Those will cancel. And feet to miles, I do know. Do you know feet to miles? If you went to our middle school,
Feet to miles.
Oh, yeah.
500
5 tomatoes, right? 5 tomatoes. 5280. 5 tomatoes, right? So 1 mile is 5,280 feet. Okay? So right now, we are in miles per second. We want miles per hour. So we're where we want to be with our distance unit. Now we need our time unit to convert. Okay? So here's what we're going to do. Those seconds need to turn into hours. Where do the seconds need to go to cancel? Look where they are. The top, right? Right now they're on the bottom. So to cancel it out, you need to put it on top, which is kind of reverse of what we've been doing. So you're going to put seconds up here. And seconds turns into what? Nope, time units. Minutes, right? Seconds to minutes. How many to how many? How many seconds? 60 seconds in 1 minute, okay? So our seconds just canceled. So right now we're at minutes or miles per minute. We want miles per hour. So we need to convert those minutes. This is our last one, guys, into hours. So where are minutes going to go to cancel? On the top. Minutes here. What's going to go on bottom? Hours on bottom. And what are our numbers? 60 minutes in 1 hour. Okay, so our minutes cancel, and we're in hours and miles, which is what we want to be in. The issue is we have a whole bunch of numbers, right? So here's what you're going to do from here. You're going to multiply all the top numbers. So you're going to do 50 times 3 times 1 times 60 times 60 and get this number, 540,000. Okay? Then you're going to take all the bottom numbers and you're going to multiply across. So 5.8 times 1 times 5,280 times 1 gets you this number, 30,624. Okay? What do I do with that? Divide. So you're going to go 540,000 divided by 30,624, and you get this number. What does that mean? 17.6 what? Not close. No. Look at what I have circled up here. What did we end up with? What were they looking for? Miles per hour. So that means the 50-yard dash in 5.8 seconds, that guy can run 17.6 miles per hour. That's fast. Yeah. Yeah, you may go to the bathroom. That's it.
Okay, so if I did the 40-yard dash in 4-point-something seconds.
Do you know your number? 4.5?
No.
And you want to figure out how many miles per hour you can run? Here's the deal.
This is just